students, we're going to go ahead and go over pH calculations in this presentation. So we're going to be on page 11 in your packet. But first, before we go there, I really want you guys to take a look at this handy dandy tool on page 2 in your packet. It's this magic pH power box. Now, on your test, I'm going to give you all of the equations that you need, you know, your 10 to the negative, your negative log equation, your pH plus pOH equals 14. You'll hear all of these, but the test doesn't tell you guys how to use your equations. But when you look at this pH power box, it tells you how to use your equations and how to solve. So for example, if I have my hydrogen ion concentrations and I'm trying to find my pH, I know I have to go from here down here, and so it's going to tell me I need to use this equation. But if I have to go from, example, my pOH to my hydroxide ions, I have to go up in this direction. So it's telling me that I'm going to use this equation. So this is a very, very handy tool to use when you're trying to figure out how to do your pH calculations. First, we're going to start by relating pH and pOH. So one of the other videos talked about how these are opposites of each other. When pH is low, pOH is high. When pH is high, pOH is low. And they're equivalent to 14 because the pH scale is out of 14 essentially. So that's why the pH plus the pOH is equal to 14. So in this example, we're trying to find our pOH, and we're given a pH of 4.6. That means 4.6 plus our pOH equals 14. So we just have to subtract from 14. So our pOH then would be equal to 9.4. Now, pH and pOH do not have any units, so we would leave our answer as 9.4. It asks if it's acidic or basic. Well, this one is going to be acidic because the pH is less than 7. Down here, it's asking us to find the pH, and it's giving us the pOH. So we know that we have to go from the pH to the pOH. So our pH plus our pOH is equal to 14. So our pH then is going to equal 5.8. Nope, I can't do mental math. 7.8. Goodness gracious. 7.8. So is this acidic or basic? Well, it's going to be basic because pH is greater than 7. Okay, so easy peasy going between pH and pOH. So next we're going to look at relating the hydrogen ion concentrations to hydroxide. And so we have our two equations that we're going to use here. I call this the negative log equation, and I call this the 10 to the negative equation. So one thing that we want to make sure that we remember is that when we see brackets like this, those brackets mean concentration. And we talked about concentration in our last unit, and concentration is measured in molarity. And the units, remember, are going to be big M. So if you see something with big M, that's giving us our concentration, okay? So with example 1 here, we're trying to find our hydrogen ion concentration given the pH of 3.8. So when we look at what we have pH, we're trying to find hydrogen ion concentration. We're going to use this equation here. So our hydrogen ion concentration is going to equal 10 to the negative pH. So that means that it would be 10 to the negative 3.8. So I'm going to go ahead and switch, trying to use my hover cam so I can show you how to input this into your calculator. So I'm going to stop sharing this one, and I'm going to share my hover cam. And so hopefully this is showing up here. Okay, so when I do this, I'm going to take second, I'm going to hit this second log, and that's going to see 10 to the, and it's already going to give me an exponent, and then I just have to put in my pH, so negative 3.8, and I would enter. So my answer would be this, but I'm going to round it to the appropriate number of sig figs. I get 2 sig figs based on my pH, so my answer would be 1.6 times 10 to the negative 4. So I'm going to go back to the presentation and share my PowerPoint again. And sorry, I'm just trying to get everything situated here. My answer would be, so my work has disappeared, but I can still put my answer here as 1.6 times 10 to the negative 4. And units of concentration are going to be the big M molarity. So when we look at example 2 here, it's asking us to find the pH, and it's giving us our hydrogen ion concentration of this. So that means we're going to use this first formula here, because to find pH, we need to do our negative log of our hydrogen ion concentration. So we would find negative log of 4.73 times 10 to the negative 8. So again, I'm going to stop sharing this one, and I'm going to switch to my hover cam so I can show you how this looks on the calculator. I've got to change the video over here. Okay, so this time I don't hit the second sign. I'm going to hit my negative sign down here, negative log, so it should look like this. And then I'm going to put in my 4.73. Now don't forget, we're going to use the second EE button, and that takes care of the times 10 to the, and then I just have to put in my exponent, negative 8. And this would be my pH. And I'm going to round it to 3 sig figs because my concentration was in 3 sig figs. So my answer would be 7.33. Okay? So let me stop sharing, go back over here. Sorry, this is a lot to do. So it just takes a half second. Okay. So our answer for the second question is going to be 7.33. And pH and POH don't have units, so that would just be our answer here. Okay? So when you look at POH and the hydroxide ion concentration, it's going to be the same formulas. It's just that here we've substituted H's or OH's for the H's. So we want to make sure that we know if we take the negative log of some kind of concentration, that pH or POH scale has to match. So if we take the negative log of hydroxide, it's going to give us POH. If we take the negative log of hydrogen, it's going to give us the pH. And the same thing down here, if we take 10 to the negative POH, we're going to get hydroxide ions. If we take 10 to the negative pH, we're going to get hydrogen ions. But otherwise, those formulas are the same. So let's look at example 1 here. Which of these two equations, top or bottom, are we going to use for example 1? Well, we're trying to find our hydroxide ion concentration, and it's giving us our POH. So we're going to use 10 to the negative POH is equal to our hydroxide ion concentration. So that's going to equal 10 to the negative 9.94. So again, how is that going to look on our calculator? Well, let me switch over here so I can show you how we're going to do that. So again, we got to get 10 to the negative, so we're going to do second log to get 10 to the negative 9.94. Okay, and that will be it. So we want 3 sig figs because our POH had 3 sig figs, so our answer would be 1.15 times 10 to the negative 10. Sorry, it just takes a hot second to get all switched around here. So 1.15 times 10 to the negative 10. And units for concentration are big M molarity. Now, example 2, which equation are we going to use? We are going to use the top equation, the POH is equal to negative log of hydroxide, because we are looking for our POH, that's our unknown, and it's giving us our hydroxide ion concentration. We know that this is that. So when we solve for this, we're going to take our negative log of 4.88 times 10 to the negative 6. Oopsie. So our calculator again. So we would have negative log this time, no second here, negative log of 4.88, second E, negative 6. So our answer would be rounded to 3 sig figs because the 3 sig figs here, 5.31. Oops. Yes, again. Okay, so let's see here. Sorry, everybody. So our answer for example 2 is 5.31. 5.31. So those ones are pretty simple, just using a one-step problem. So if you have any questions about those, just let me know. Now, these next ones are going to look at multi-step problems, combining pH and POH and hydroxide and hydrogen. So we're going to look back at our magic pH square, but I'm going to write out what we have first. So in example 1, we've got, we're trying to find our hydroxide ion concentration. That's what we're trying to find, and we know that our pH is 8.4. Just for time's sake, I'm going to write out what we have for example 2. We're trying to find our POH, and we have hydrogen ion concentration of 4.92 times 10 to the negative 5. Now I'm going to go back to this magic square pH power because that is going to help us to solve these problems. So let's look at example 1 first. With example 1, we are trying to go from here up to here. That's what we're trying to solve for. So you can see that we have one of 2 paths that we can take. I find it easier to use this bottom path whenever possible because that is just subtracting from 14, okay? So I'm going to go from left to right here. This is going to be my step 1. And then I'm going to go up to my hydroxide ion, and that's my step 2. Sorry, that was a terrible arrow. So first I'm going to go from pH to POH. So I'm going to take 14 minus my pH of 8.4, and that's going to be 5.6. This represents my POH. Once I have my POH, it tells me I'm moving up to get to my hydroxide ion concentration. I'm going to take my 10 to the negative POH. So I want you to plug this into your calculator to see if you remember how to do this. You're going to do your second log, negative 5.6. So So I forgot to write that here, 10 to the negative 5.6. And our answer for our hydroxide ions should be to 2 sig figs, 2.5 times 10 to the negative 6. And that's going to be molarity. So this would be our final answer here. Okay. Let me go ahead and clear this. Now in example 2, we were trying to find our POH, and we were given our hydrogen ion concentration of 4.92 times 10 to the negative 5. So when we look at our magic pH square box here, I know I call it something different every time, we are starting up here this time, and we're trying to get down here. So again, you can go left to right and then down, but I just find it easier to go across the bottom whenever you can. So I'm going to go down first. This is my step 1. And then I'm going to go to the right here, and that's going to be my step 2. So I'm going to first solve for my pH. So pH is going to equal negative log of my hydroxide ions. So I'm going to have negative log of 4.92 times 10 to the negative 5. Now I want you to plug this into your calculator to make sure you're going to get the same answer as me. 4.92, second e negative 5. So we should be getting here that our pH is 4.31. And we're trying to find POH. So my step 2 now is I'm going to subtract that from 14. And my POH should be 9.69. And that would be my final answer. No units on pH and POH. So those are all of your calculations. If you have any questions about how to do those, feel free to reach out and I am happy to help. Okay, bye.